Hello, everybody. My name is Kamran Habib. I'm a senior solution architect based out of Dubai. I have been with AWS for close to 4.5 years now, and do focus on security, application modernization, and solution architecture. Right. So, moving on. All right. Gonna go. All right, so the session today will be talking about raising a bar with security. When we think about on-prem, how many of you are running on-prem data centers right now? Just a quick show of hands. No? So on-prem data centers, yeah. So are those who have run in the past, you would have noticed that that on-premise security is challenging. Suppose you configure a switch or a router, or somebody in the server team launches a server, or a security team does an action. How do you get visibility across this on-prem? It is a very challenging issue for customers running it. And you have lack of visibility, you have low degree of automation for that, right? So that's why before, you wanted to move fast, or you have to stay secure. You had to go through and break some of your security standards in order to move fast. And every time you wanted to move fast and security came in, it throttled your movement to go fast. But with cloud, with AWS, what this does is you can move fast and stay secure. I'll give you an example. Every action that you do in AWS, whether it's creating a VM, whether it's launching a container, whether it's implementing security standards, whether it's from the console or from the CLI or from the SDK, every action is recorded. Every action is tracked in something what we call Cloud Trail. So all the actions are recorded. So any action that your team does, even if it's of hundreds of thousands of engineers, that action is recorded, and you have access to that. And that's why we have customers such as HSBC running security workloads. We have Citra from Kuwait that is running security workloads. And Southwest, they use AWS to run their workloads because of the security standards we provide. So what are the things we use? What AWS does is it raises your security services, your security-related services, right? First thing you get is you inherit your global security and compliance standards, your compliance controls. So every compliance control we have, and we have the most compliance controls of any cloud, you inherit because you're running your workloads there. The second is you scale with superior visibility and control. We have thousands, if not millions, of customers right now. We have visibility across these customers, and we are learning, and we're constantly evaluating threats. So we have that scale and superior visibility and control that we have. We also have the highest standards for privacy and data security. Everything we do is encrypted, whether it's within the data center, the transit, or the data we keep is encrypted. And we automate. One of the key things that cloud provides us is the ability to automate those things. So when I talked about you being able to record every single action, what's the point of recording those actions when you don't take action on that? And that's what that's what the tools we have provide you to do. You can automate and reduce risk so you don't have manual intervention in your processes. And we have the largest ecosystem of security, partners and solutions. So Mohammed Mustafa showed some of the partners. We have extensive list of software partners. We have partners such as FORTE Cloud as well that implement those solutions. We have one of the largest ecosystem of security partners and solutions. So I talked about inheriting global standards. You're inheriting these standards. These are all the major standards that we have. We have others. You can see them on your console. We have a service called Artifact, which shows what are the standards that are available from a security perspective. But that's why a lot of customers choose to run workloads on us. Banks, financial institutions, government agencies, they run their workloads on us because they inherit these standards that we provide. Second thing I talked about was scaling with superior visibility. You control where your data is stored and who can access it. You have fine-grained identity access. You can restrict it to one single person or one single group of people, or the security team on who accesses what. And especially in this day and age of ransomware and malware that are attacking systems, it's highly important how restrictive, how granular we can get in terms of security. And it's only based on least privileged access to your system. You reduce risk via security, automation, and continuous monitoring, and that's what we provide as well. And you can integrate with AWS service and solution, and that's one of the key benefactors. So if you're using, let's say, a database-based security or a container-based service, you can integrate that with our services, and it's a very tight integration that we provide with our security services. The third thing I talked about was the highest standards for privacy and data security. So we meet your data. We have 27 regions now, 87 availability zones across the world. You can choose an AWS region, and AWS will not replicate it elsewhere unless you choose to do so. So that data that you've put into a region or a particular local zone, that stays in unless you explicitly ask that to be replicated. We provide encryption at scale. We have a service called KMS, or Key Management Service. Every single action that you do on a service, such as RDS, S3, we have KMS backing with that. And you can encrypt all your data at rest with KMS. Complying with local data privacy laws by controlling who can access, what they can access. So when your evaluators come and audit you, when the auditors come and audit you, you can show exactly how you're complying with your local laws. And then access to services and tools that enable you to build that compliant infrastructure on top of AWS. So one of the key things that every time you hear a security presentation from AWS, you will see this slide. We talk about the shared security and responsibility model. Basically, we take care of security of the cloud. That's our responsibility. Infrastructure, whether it's your hardware or physical access to the hardware that you're running, to the hypervisor that you're running, we are taking care of that. However, when you are implementing your workloads, your data, you have your S3 bucket configured, your storage bucket configured, you have your database systems, it is how you configure and control it. And that's why it is really important for us to work together to ensure that when you're designing your workloads as solution architects, as partners, one of our responsibilities is to ensure that when you're running workloads, that you are implementing security controls on it. And that's why security in the cloud is the responsibility of you as customer when you're configuring your workloads. So there are 6 things that I'm going to talk about in terms of how we do security. One of the first thing is security foundations. The key best practice that we have, how you set up the initial foundation, how you set up the initial accounts on AWS. What we are recommending right now is that you separate your accounts using workloads. So if you should have a security account, you should have a logging account, you should have a workload-specific account. And that's what you get with what we call the concept of AWS organization. AWS organization on the top, it provides you with the account structure, and under it you can create multiple accounts. So for example, in my slide I have management account created, which has services such as organizations itself, control tower, an ability to spin up further accounts, and then a single sign-on, so that you have a single sign-on identity across your entire organization. So rather than using account-based permissions, you're using single sign-on to log into your accounts. Okay? And then you have your log archive account. So all your logs go into this account. Now again, what this provides is it's totally isolated accounts, totally isolated containers. So in case there's a breach in one account, hopefully not, but in case there's a breach, there's no lateral movement that can happen by the attacker. So you have your log archive account, and you have specific permissions, specific teams that are accessing it. Whether it's CloudTrail, what I talked about, every action is recorded, or you have config. We have a config as a service, which takes the automated action that I talked about. So you can say config. If you see this person logging in from this account, block their access. If you see this person trying to instantiate a really large instance, which is going to cause cost incursion on my account, you can block this creation. So you can take those actions, prohibit that, and you can also take reactive action. If somebody has done something, you can go and you can block those access. Then you have the operations account, where you have your operations team or even your security team. You have things like Security Hub, which is giving you visibility and aggregating all the information it's getting from different AWS services, such as Guard Duty, such as Macy. All these things are getting integrated in Security Hub. And we have integration with partners as well with Security Hub. as well, so to get that visibility. And then guard duty, one of the most important service, I would say, for security, if you're running AWS workload, is very easy, one-click option to enable guard duty. It does anomaly detection across your accounts, all your accounts. So you can enable it across organizations. It's doing machine learning-based anomaly detection based on users, based on VMs, based on databases, based on even containers. So if you are running things like Kubernetes or Docker containers, it's even doing inspection on that. So if it sees, it's learning the behavior of your account on how you're using that. And if it sees an action happening, it will inform you and alert you. And again, when you get alerted, you take actions based on that. We have the well-architected tool. We are talking about security, and well-architected is one of the best practices. We as solution architect, FORTE Cloud as partners, we will help you do well-architected reviews of your workloads as well. And you can do that yourself. All that in the operations account. So config, I talked about. CloudFormation, infrastructure as code. Not spinning things manually, only allowing people to spin through code. And there's no other way to spin it. If you only pipelines and codes are spinning infrastructure up, you're restricting access, you're automating the pipeline. And then Trusted Advisor, which is giving you access across multiple different services, whether it's security, whether it's cost optimization, performance. Trusted Advisor is giving you that access across your account, right? And then you have your workload where you instantiate, whether you're running it on EC2 or containers, and you have S3, that's a workload 1. And then you can have another workload 2. I have a typo there, workload 2 account, so you have a different set of workloads. So you can divide, depending on the workloads you have, you divide that account. So that you get that containerized structure. And one of the key things that I'm just putting this here, when I talked about organization, you can restrict across your entire organization a certain action. So if you want to say that I don't want anybody to be able to create a user, an IAM user, identity and access management user, that should be denied across the organization. Only certain accounts or certain permissions, certain people can have access to that. And you can restrict those policies. You can say, I don't want to spin anything in this particular region at an organizational. So even if you create accounts under it, they're prohibited by that. And this is how we do the policies. Everything is restricted based on these JSON-based policies that you can create and automate. Okay, so what I'm going to do quickly right now is I'm going to go through a workload that you're running. Okay, so you have a simple 3-tier application. It could be a WordPress where you have an instance, where you have Aurora, our SQL database. You can run MySQL or Postgres on that, and you have Lambda as our service. Okay, and then we also have S3, our storage service. And we have our simple notification service, which is SNS. So anytime there's an alert, SNS can send those messages to you. So I'm going to go through that, and we talked about security foundations. Now I'm going to go through identity and access management. I've already talked briefly about that. IAM is really the key to your security, your accounts, on how users are accessing those accounts. Okay? So let's look at identity and access management. Some of the key best practices we implement is identities, on how users are getting those identities. Right? So we have organizations, we have control tower is implementing those accounts, and then we do SSO. I mentioned that briefly before as well. This is single sign-on. So you use single sign-on to give access to users across different accounts. So somebody in the security team can access, let's say, only security account. Somebody in the workload 1 team can only access that workload, and they cannot access other accounts. And you can restrict decisions based on that and centralize identity across all your accounts, whether you create 10 accounts or 100 accounts or however many accounts. We have customers that are scaling to thousands of accounts in their organization. One of the key things is to have strong sign-in mechanisms. So I talked about SSO. There's another aspect, MFA. Every single account, as soon as you create, even if it's your own personal account, please do multi-factor authentication on it. Right? You have to, if your account gets compromised because there's a credit card tie-in or a payment system tie-in, a hacker can go in and get multiple access to it, can really cause chaos in their account. So MFA is very critical, so strong sign-on mechanisms. Audit your credentials. We have a credential auditor as well. I talked about CloudTrail giving you all API access. We also can audit your credentials. We can say these access keys have not been rolled. These users have not accessed these accounts. you can go and audit all those at a regular interval level. Other things in terms of identities, use temporary credentials. So when we have services such as EC2, which is instances, Lambda or serverless function, Aurora or database that I talked about, you can give them a particular role. So you're not giving them static, long-lived permission. You're giving them access based on time-based role, what we call STS tokens, and they get those access based on the role that you have assigned. So you can say that instances can only access Lambda. Aurora can only access notifications to SNS. So you can restrict those access. And the other thing is when you are accessing something like Aurora with the database, you would use username and password. Generally, people go to a jump server, try to log in, and they're using clear text password, clear text username, which could be a risk. So we have something called Secrets Manager, where you can store encrypted your critical, your sensitive passwords. And this is available just as an API call that you call in, and the service calls that Secrets Manager. And so you don't have to store your passwords, username on local machines, on your own computer. You access it using API with the Secrets Manager. And then I talked about SSO. One of the key things, even if you are using CLI, AWS SSO provides you the CLI access. So not just with console, users can log in through CLI as well using SSO. The next thing is permission. So you share your resources securely, you analyze your public and cross-account access, and you only grant privileged access. You can see that this is the console. We can look at all the active findings, the access analyzer finding, and it's giving you that access on who's accessing what. So you can start restricting the access if you see there are too permissive policies. So I talked about security foundation. We talked about how organization structure, logging into the account. We talked about identity and access management. The next step, once you have done identity and access management, is to do detective controls. How do you detect what's happening in your accounts? So you have detective controls. We have things like Security Hub. I talked about that. We have guard duty. We have config and CloudTrail. All that is you configure the service and application logging for that. And then you analyze those log findings and metrics continually. So suppose something happens to your instance that gets reported on CloudWatch, and then you can start even those CloudWatch actions. You can take action based on that. And then also for long term, you can store those logs into an archive account. So again, you're using that structure, the organization structure, and the different services. We also have what we call Security Hub. I talked about that, where you're integrating all the information you're getting, consolidating from different services into Hub. And we have foundational security best practices that you can implement, such as NIST and these. And once you instantiate it, you'll see your compliance level to those standards as well. And I talked about one of the key things is detection. So with guard duty, once you have detected, you can do actions based on whether it's a Slack message or a Chime message or Amazon Chime, or you have some other tools such as even SNS. You can have email-based notification. So whatever process works for you, we have customers that are automatically creating Jira tickets based on some of the security findings that, especially critical findings that are happening based on guard duty findings. So implementing those is very, very essential. Then, so we talked about security foundations, IAM, we have done detection, detective controls. Now we talk about infrastructure. So for those infrastructure folks with networking and security background, this is when you're looking at your VPC and how you have defined your structure. So we talked about the different applications that we have, right? So first thing is we create our network layers. We have our account, we create the VPC. VPC is your own virtual private cloud. Enable it, it's restricted by you, it's only for you, it's carved out for you in AWS. That's your VPC. You're giving access to your VPC. You can have Route 53 to guide your traffic using DNS space. You have CloudFront or CDN. You have web application firewall or layer 7 detection. It goes very well with CloudFront. And you have your VPC as you define it. And then you can define the way you define your workload. You can say only in the public subnet. Now we're going into the network concept. Only publicly, my load balancers can be accessed publicly. But everything else right? Oh yeah, we also have the shared, whereas for a NAT gateway where you want outbound traffic to go, you can configure that in your public subnet too. But then your application, your instances, your Lambda all run in a private subnet, so that it's not available to the public, right? The only way to access this is through via the load balancer as you're accessing it. And similarly with the database, you can restrict it, saying that only the application layer is going to access the database. There's not going to be any other way to access the database. Again, you're restricting least privilege policy that you have. So you create your network layers. Then you control traffic at all layers, right? So you start controlling traffic at all layers, which is what we call the security groups and network access control lists, NACLs. So security groups would be something what we call the stateful layer 4 based firewall. It does TCP, HTTP, those blocking at that level. So your layer 4 stateful firewall. Once you implement it in one direction, it automatically knows in the other direction. And then you also have access control lists, which you can define at a subnet level. So security groups are at the instance level, and NACLs are at the subnet level. So you're blocking anything from coming. So at the instance level, you're blocking it, and then you're blocking it again at a subnet level. Multiple layers of protection. And then after that, you implement your inspection and protection, right? So you have things that, sorry, going back, too much. You have CloudFormation, which is doing the implementation, and then we have something called System Manager, a very powerful tool, which you can use to provide access to your account. And also, we've talked about inspection and detection as well in terms of config and security hub. So reduce your attack surface. We have services such as Inspector, which is doing vulnerability assessment. We also have EC2 Image Builder, so you can have standardized golden images. You were enforcing that only this image can be spun up. Nobody else can spin up their own flavor of instance. We also have ECR, which can be restricted. ECR is our container repository. So if you are doing containerized-based workloads and you want to restrict it to AWS accounts only, your AWS accounts, implement them in ECR. We also have public repos available, image repository available for ECR as well. So all that, you're basically reducing your attack surface at an infrastructure level. All right, so we've talked about foundations, we've talked about identity and access management, we've talked about detective controls. We have already protected our infrastructure now. Now, what about, we haven't done anything with the data that you've had. So you've collected data, you've done, like Izza's talked about machine learning, AI, ML, all that data is there. You're doing analytics. I think next session is going to be talking about analytics with Ismail. So you'll be doing those analytics, but what about that data? Do you want to just keep it the way it is? And that's where we look into data protection, right? So, oh, sorry, wrong button. Look at data protection. You're keeping people away from your data. First thing is, if you don't have the need to store, don't store it. No point storing data that you don't need. So be selective of what data you store. And when you do store it, don't grant access to it. Don't grant access unless explicitly needed. And again, as I said, it should be given access based on automated pipelines. People should not really have access to that data. So you shouldn't be having jump hosts accessing data using username, password. It should be an automated way of accessing data. Encrypt your traffic. I talked about KMS. Almost every service that we have that has data backed on it, KMS is generally supported. We can look at which the exact matrix is, but like major services such as RDS, you have Lambda, all those have encryption. So you're storing your data at rest. You're masking it, you're tokenizing it. All that data, you ensure you do that. You isolate your data. You don't connect multiple systems to it. You have tooling across it, and as I mentioned, you eliminate human access. And then everything you do, you control it with version control, and you use operation as code. So that way, you're tracking it. Any change you make, you can revert back as well to it. So going back into data protection, we're looking at something called Amazon Macie. Amazon Macie, your critical data, your data lake, will most likely be on S3. And S3, Amazon Macie identifies the data within your workload. So even PII data, it can look at that and then give you alerts based on that, and you can define actions based on that. You should implement key security management, right, with KMS. and enforce encryption at rest and in transit. So enforce that as part of your organization. Again, services, you can enable default decryption by default. So anytime you spin up an EBS volume or you spin up EBS storage, you know that it's encrypted at rest. The last is incident response, right? We have done all those other things, but how do you, if things do happen? As our CTO, Werner Vogel, says, everything fails all the time. Never expect that things are just going to work based on something you read. Expect that things are going to fail. Expect that there will be break-ins into your system. So how do you respond in case there is something? Firstly, develop an incident management plan, right? This is a simple Markdown-based template. You can define these plans. You have things like scenario title, malicious IP action in this case that I have, and API was invoked. What do you do once you have? What does your team do when that happens? There should be a standard playbook for your team to look at. Cloud Clear and application log, gather that. Cloud history of IP, open up a high severity InfoSec ticket. All this could be automated as well. And then disable credentials, remove resources. I have the link there and down there. I can give you that later. These are example runbooks that you can have in your organization that you can go through and run as well. One of the key things, and that we highly recommend, we have this as well happening, and Netflix is the leader in this, is to run game days, to do failure testing in your organization, to do chaos testing, what we call Chaos Monkey is the tool that Netflix developed. So you should be able to randomly implement break-ins in your organization and have a way of running it and knowing what happens, right? So schedule a time, find a price, gather as a team, find a price, supply food and drinks if you have to, get in a room, and pick, let's say, a guard duty finding that you have, and create a playbook based on that, learn and have fun. So that's one of the games, but implement that as part of your culture, as part of your organization. Again, key best practice for incident response, pre-provision access and tools, right? So you have your operations account, you can configure your tools such as Athena, that Athena will do SQL-based access in your logs, such as Cloud Trail logs. In S3, it can look at your archive, so you can have these provision access tools so that you don't have to waste time defining the process and doing when the things do happen in your organization. This is the NIST guidelines for cybersecurity framework. It's mainly designed to talk about ransomware and how organizations too should implement security best practices. And they divide it into that as well. So they have identity, right? Identify. You have to protect, you have to detect, you have to respond, and then you have to recover. And that's why when we look at our security solutions that I've discussed very quickly, I know for people who are new to AWS or those that have not used services, this might be a lot of services that we're talking about. But you can see that's the way we are thinking about security. And that's the way we are raising our game, right? So we have, whether it's detect, the tools that we use for protect, what we use and how we automate and respond. And one of the key things that I want to talk about is in case all these tools you implemented and you still get a breach, then we have things like AWS Backup. AWS Backup has multiple auditability. It has ways to implement ransomware protection as well. We also have Cloud Endure, which you can use to, especially if you're migrating VMs, even from cloud to cloud or from on-prem, you can do continuous replication on that. We also have a database migration service, which can do replication of database. So we have multiple tools to help you move data from one region to another region. And especially at AWS Backup, at an organization, you can define the policies and define where your data needs to be backed up. Right. So with that, just closing things off, we have a large community of security partners. I talked about that initially. You can see from our marketplace, a lot of these partners are available, and you can choose them in terms of all the options that we have, right? And like to this slide, just going back one slide again, you can see that there's a lot of services. So that's where us, as solution architect, partners such as FORTE Cloud, Mustafa that just spoke, can help you define and really understand these workloads. So engage us, and we will be able to help guide you in terms of implementing your really secure AWS environment. With that, I'd like to end. Thank you.